Greetings, everybody. So I want to take this chance to show you how to solve this problem, which I'm finding on my math lab. And at least at the time I'm making this video, it's from assignment 3.3. And it says to find the derivative. Dy over dx is our symbol for the derivative. If you want to be a little more specific about it, it's the derivative of y with respect to x for the equation using implicit differentiation. Okay, so I will show you how to do that problem, but I want to try in, say, 30 seconds to a minute, tell you the story about what implicit differentiation is. I've already made a video to introduce what this is, but I want it to be on your mind as I show you how to solve the problem that I started the video with. Okay, so quick story. I'll try to do it 30 seconds to a minute. So there are two scenarios that we run into in this class. You might have an explicit function, and those put y in terms of x. They're solved for y. You put the x in, you do all the calculations, you get the y back out. One x in, exactly one y back out. Those are explicit functions. And if you want to find the derivative of those, there's a formula that is applicable to each type. Like for 4x squared, there's a formula for the derivative of that. E to the 2x, there's a formula for that, so on. But you might have this scenario where you have an equation and it's not solved for y, okay? Would it still work like this? Do you think in this equation, even though it's not solved for y, there's still a way somehow to plug an x in and figure out what y should be? Yeah, it's still possible, okay? So in this equation, even though it's not solved for y, if I put one x in, somehow there's a way to figure out what one y I'll get back out is, okay? When we have an equation like that, it's called an implicit function, all right? Implicit function is not solved for y, but, you know, it's at some level operates just like these, okay? All right, now suppose we want to talk about how to find the derivative of such a thing is going to be. Now, I put here to tell you a little bit about that, to say, well, you know, y is a function of x question mark somehow, okay? I don't know the formula that if you plug x in, you get y directly, but somehow it's possible, like in this equation, somehow, you know, you plug x in, you get y back out. So when I put like this, y equals f of x question mark, I'm just saying like that represents the possibility that I could do this. Now, okay, to show you how you'd find the derivative in such a situation, I'll, by analogy, show you this one. What's the derivative with respect to x of 1 minus 2x to the fourth power? Okay, well, there we would use the chain rule. We bring the 4 down. 1 minus 2x, we take 1 away from the 4, get 3. And then we would find the derivative of this inside thing, and that's negative 2. The derivative of 1 minus 2x is negative 2. If I wanted to find the derivative of like y to the 6th power in the midst of some equation where it's not solved for y, assuming that somehow that y represents a function of x where if I plugged in the x I could get the y, I would do that the same way as this. Okay, I would bring that 4 down, I would take 1 away from it, but then when it comes time to find the derivative of the thing that is right there that gets that power, I would just have to say it was y prime, you know, because here, like, I don't know, you know, question mark, what's y? Like, I don't have an explicit expression for that, okay? All right, so that's how we handle the derivative of such a thing in the midst of some bigger equation, all right? That's an implicit function. Okay, so then that gives rise to this procedure that if we want to find the derivative of y with respect to x in an implicit function, we just take the derivative of each term on each side of the equation with the appropriate rule, whatever it is, and we multiply all derivatives, all y derivatives by y prime, and then we solve for y prime. Okay, so that's the 30 seconds to a minute. I don't know how it felt a lot longer than that. Probably because I was trying to fit such a big topic into a short period of time. But let's do the problem that I introduced the video with, which is this one. Okay, so here's how we would approach it. I want to find the dy over dx. You could also say that was y prime if you wanted to for this equation. I write this down to express my intention that I'm going to find the derivative with respect to x of each term on each side of the equation. When I find the derivative of x to the third times y squared, I would have to use the product rule because that's a product of two things, x to the third times y squared. So what you're looking at here is the product rule. So what's the product rule? If we had the derivative with respect to x of one function or one thing f times another thing g, that would be f prime times g plus g prime times f. Okay, that's what the product rule is, and that's, like I said, that's what I have here. The derivative of f times g plus the derivative of g times f. So in my case, that'd be the derivative of x to the third, which is 3x squared times y squared, f prime times g, plus derivative of y squared, which is what? The derivative of y squared, I guess ordinarily we would say is 2y. Why am I saying it's 2y times y prime, though, in this case? Well, two answers to that. One is that that's what the procedure says to do. It says multiply all y derivatives immediately by y prime. Okay? So that's one answer. Another answer is, what does the y represent? I mean, I guess we'd have to think a little bit philosophically about this. What is the y in that equation? It's some function of x which is not revealed. That in this equation, if I know what x is, there's a way to figure out what one y I get back. Because a function is plug x in, get one y back out. So that's why I have to do it. So it's bring the power down 2y to the first power, but then I'd have to use the chain rule and find the derivative of that inner part there, which we're just going to have to say is y prime. Okay, so that's the reason for it. So that's g prime times f, all right? And then what's the derivative of 3? Well, what does the rule say about that? What's the rule say the derivative of any constant is? It's 0, okay? All right. So I get my equation then as a result of my first step. Take the derivative of each term on each side of the equation with whatever rule is appropriate. Okay, I'd have to use the product rule here, and I'd also have to know that the derivative of any constant such as 3 is 0. Now what I do, because I want to know what the derivative is, I want to know what y prime is. Hopefully you find it understandable that I would take that equation that I just had and I would solve for y prime. See, it's right there. I'll solve for it. I'll try to turn this into some statement that says y prime equals, and whatever I get that it's equal to will be my answer. So I would, for example, I would subtract this term on both sides, and that would put it over here as negative 3x squared y squared. Then, if I want to solve for y prime, see, I have 2y times y prime times x to the third power. Since this is all multiplied together and I want to solve for y prime, I would divide by 2y times x to the third power on both sides, and I would get like so, okay? All right, and then I've solved for y prime. It would only be a matter of reducing what is reducible at this point, you know, so this might be my answer, but is anything up there unnecessary? Like, so for example, you see I have x squared over x to the third power. You know, I've got that as a component of my answer. Well, that does reduce to a 1 over x, right? 2x is up here, 3 down there. I could cancel 2 and leave 1 behind. So, okay, I cancel x squared and x to the third power, leaving me just an x. And then likewise, I got y squared and y. So if I had y squared on top, y on the bottom, 2 up here, 1 down there, it'd leave me 1y on top. So okay, there's my final answer then, negative 3y over 2x. So all right, let's try putting that in just to finish this off. So I'll do negative, and I want a fraction. What was it? 3y over 2x. Okay, so 3y over 2x. Okay, and I check it, and it's correct.